Hi everyone, in this video we're going to go through the solutions to the Year 9 Maths practice exam. Okay, so just make sure you're aware of all the details of the exam. During your reading time, you don't really need to, During your reading time, you should look at which questions you can do and start with them, because you don't have to do the exam in order, from question 1 to question 15 in the multiple choice and then doing the short answer. If you think that there's a section on the short answer that's your strength, then do that first. All right, anyway, let's get stuck into the solutions. So section A, multiple choice. Question 1. For the right angle triangle shown below, the value of x is closest to. So let me just get my pen ready. Okay, so we've got Pythagoras' theorem, so c squared equals a squared plus b squared, and then we're just substituting the values in, so make sure you label your triangle. Now c always has to be your longer side, or the side opposite your right angle, and a and b can be the other two sides, so it doesn't matter which one's a and which one's b. So c is 1.5, a is 1.3, and b is called x on our diagram, so I'm going to call it x here. All right, so to get x by itself, we're just going to subtract 1.3 squared from both sides, so that goes. So x squared is equal to 1.5 squared minus 1.3 squared. So you'll just notice I switched sides. So I put our unknown on the left side and everything else on the right-hand side. All right, to get x by itself, we do need to take the square root of 1.5 squared minus 1.3 squared, and then we just put that into the calculator. All right, so remember it is closest to, so I get, when I put on my calculator, 7, let me just do that again, 748. We're not rounding here, so I just have to find what is closest to that, and that is option D. All right, question 2. For the right angle triangle shown, the value of x is given by, so again, writing the formula, so c squared equals a squared plus b squared. Make sure you label your triangle, so c, a, and b. Notice how I do c first, because c is always your longest side. Okay, or the side opposite your right angle. All right, substituting everything in, we get 1.6 squared equals x squared plus 0.9 squared. We want to get x on its own, so I'm going to subtract 0.9 squared from both sides. All right, so that cancels out, and we're left with x squared equals 1.6 squared minus 0.9 squared. And then to get x by itself, we take the square root of both sides. All right, so this one we've actually left in this form. We haven't put it into our calculator. So the correct answer for this one would be B. All right, question 3. The slant height of the following cone with diameter 2.8 centimeters, correct to 1 decimal place is. So we've got a triangle within a cone. All right, so you can see the triangle has been drawn in red here, but if I go on to the other side, we're going to have the same triangle. So the height of that triangle is 2.3, and your diameter is 2.8, so half of that is going to be the base of your triangle, which is 1.4, and we want the slant height, which is S. So again, we're using Pythagoras' theorem, and then just substituting in everything. So it doesn't matter what A and B is, so I'm going to call this A and this one B, and this is side C. 1.4 squared plus 2.3 squared. So S is equal to the square root of all that. And just put that into your calculator. Sorry, got to pause it while I do it. All right, so I get 2.692 5, 8, and it keeps going, but we want to just do closest to, so no rounding that we need to do, is closest to 2.7. Okay, so just be careful not to choose 2.6, it's closest to 2.7. All right, question 4, the midpoint of the line segment joining points -1, 8 and 5, 4 is, so you need to use the midpoint formula. So midpoint. Now you've got two coordinates. Remember, you've got the midpoint of x and the midpoint of y. So x, y, it's a set of coordinates. To get those coordinates, you just add your two x values together and divide by 2, and add your two y values together and divide by 2. So with these points up here, I'm going to call them x1, y1, and x2, y2. All right, so we're adding our x's together. So -1 plus 5 divided by 2, and then add our y's together. So 8 plus 4 divided by 2. All right, so we're going to have -1 plus 5 is 4. 4 divided by 2 is 2. 8 plus 4 is 12. 12 divided by 2 is 6. So our answer for that one is 2, 6, which is E. All right, question 5, the length of the line segment joining the points. All right, so this is the length of the line segment. All right, so there's a formula that you should have on your in your notes. So it's just using Pythagoras. So what we need to do is the difference in our x's squared plus the difference in our y's squared. All right, just wanted to check that it was written correctly. So with your points, we call it x1, y1, x2, y2. So a value of x2 is 1. So 1 minus x1, so which is -3. So it's going to be 1 minus -3. Just be careful with those two negatives. And y2 is 2 and y1 is -1. So we're going to have 2 minus -1. A bit tricky with the negatives, but you're just substituting numbers in. So you should be fine with those negatives. 1 plus 3 is 4. Okay, so when you're subtracting a negative number, you're adding. So it's 4 squared. And then 2 plus 1 is 3. So we've got 16 plus 9, which is 25, and the square root of 25 is 5. All right, question 6. A letter is chosen from the word intersection. The probability that the letter is neither an N or a T is. So first of all, we need to count up how many letters there are. You can have a look at your multiple choices. I'm guessing there's 12 because we've got one option out of 12, but let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and then we've got to count how many are neither N or T. So I'm going to just cross out the N's and the T's. All right, so I crossed out 4, so that leaves me with 8, and I can see 8 over 12 isn't there. That means it's been simplified. So you've got to ask yourself, well, what's the highest common factor? So 4 goes into 8 and 4 also goes into 12. So 4 goes into 8 2 times and goes into 12 3 times. So your correct answer for that one is D. All right, question 7. If the probability of event A is 0.2, then the probability of its complement is, okay, so complement is given by A dash, and it's just 1 minus the event A. So the complement and an event and its complement have to add up to 1. So you basically say, well, what do I add to 0.2 to get to 1? I add 0.8. So it's going to be B. Complement of A equals 0.8. So the A dash means complement of A or not A. All right, question 8, the value of x in the following two-way table is, okay, so Remember, in a two-way table, your rows and columns all have to add up to each other. So we've got 13 plus what equals 25, so that's going to be 12. Down here, we're going to have 18. It's going to be 9. We don't really need to put the 4 in here, but we can. So 4 plus what equals 7? It's 3. Let's just check this row as well. 9 plus 3 is also 12. It's going to be 3. All right, question 9. The shaded region of which of the following Venn diagrams describes the set? Oh my gosh, do I not have a set written there? I knew I had one, it's just hiding. I don't know what happened there. All right, so not A and B. So what this notation means is not A and B. So we can't have any of A, but we can have B. All right, so it's actually the first one, very first one, A. So you can see how B has been highlighted, but not the intersection, okay? Because if we highlighted the intersection, it would actually be including A. All right, so make sure you've got on your notes perhaps all the different possibilities for a Venn diagram. All right, questions 10 and 11. So boxes A and B contain 4 counters each. Box A contains 2 red and 2 yellow counters, and box B contains 3 red and 1 yellow counter. A box is chosen at random and then a single counter is selected. What is the probability of selecting box B and a red counter? All right, what we might do is actually display this in a table. So we've got box A and B, and we have red or yellow. All right, so this, sometimes when there's a lot of words, and probability usually has a lot of words, it's sometimes better just to put it all into either a table or a diagram. So box A contains 2 red and 2 yellow, and box B contains 3 red and 1 yellow. So there's our information. A box is chosen at random and then a single counter is selected. What is the probability of selecting box B and a red counter? So this is where we need to actually draw a selecting box B and a red counter. Actually, I was going to do a Venn diagram, but not a Venn diagram, sorry, a tree diagram, but we don't need to. So we actually want to do probability of selecting box B and a red counter, which is here, 3. All right, so if we work out the total, so we've got 8 counters in total, so it's going to be 3 over 8. And I'm just wondering, slowly one by one, all my answers are disappearing. I wonder if I scroll, whether they're going to come back for me. Oh. All right, sorry, I had to close a few programs. So we've got box B and a red counters, there's 3. Oh, I've changed my color of my pen. And there's 8 altogether. So 8 counters altogether. So if you wanted to, you can go ahead and fill in the rest of the two-way table. So we're going to have 4 out of 3. I'm just going to go back to my red pen though. So 4 out of 3, 3 out of 8. What is the probability of selecting a red counter? So just think about how many reds we've got, and I just realized I couldn't add them up. I just assumed they were 4s. There we go, let's rub that out. I wonder if you noticed that error. Sorry, girls. My computer does not like when I use a pen. It uses too much memory. So let's pray that it can continue and it saves as we go. All right, so we've got, 5 out of 8. For question 11, so answer is C. Question 12. All right, so now we're going into some linear. So question 12, the rule for a vertical line passing through the point, -5, 9. So this question's a bit tricky because we've got a vertical line. So you need to realize that we're looking at a vertical line. Let me just draw my axes, and I might draw the line in black. So a vertical line going through -5, 9. So let's say here's -5 and here's 9. Doesn't really matter where you put it. All right, so it's got to be vertical. So a vertical line is straight up and down. There it is. And it only crosses the x-axis, so it's x equals -5. All right, question 13, the gradient of the line joining these points. Okay, so we're going to use the gradient formula. So we've got y2 minus y1, so that's our rise, over x2 minus x1. Now your points, we're going to call them x1, y1, x2, y2, and then we just substitute into this formula. So y2 is 7, y1 is -2, so just be careful with your negatives. x2 is 8, and x1 is 5. So 7 minus -2 is 9. And 8 minus 5 is 3, so that's going to give you a gradient of 3. All right, question 14, the gradient of the line 2x minus 3y equals 6. So you can't just assume that the number in front of the x is your gradient. We can only do it when it's in the form y equals mx plus c. So this equation, 2x minus 3y equals 6, isn't in the form y equals mx plus c. So we've got to rearrange it. So let's take the 2x over to the other side. That goes, and we're left with -3y equals -2x plus 6. And then we want to get y on its own, so we divide divide each term by -3. So the number in front, so we're only looking at the gradient, so we don't have to really worry about 6 divided by -3. So the number in front of the x, we've got a negative divided by a negative, which is going to be positive, so 2/3, and then 6 divided by -3 is just going to be -2. So your gradient is 2 on 3. Where are we? Option A. All right, which of the following points does not lie on the line y minus x equals 6? So remember, your points are always xy. We have the x number first and then the y number. So the first point in A, 2, 8, x equals 2, y equals 8. All right, so let's do that. 8 minus 2 equals 6. Okay, so that's true. Next, so that can't be option A. And then we've got -1 minus negative, whoop. Say one thing and write another. Just bear with me while I erase it. All right, sorry, it was supposed to be -7 minus -1 equals -7 plus 1, which is -6. So it has to be B. Let's just go and check the rest, doing it in our head. So 23 minus 17 is 6, 2 minus -4, so 2 plus 4 is 6, and 0 plus 6. Yep, good. So it's option B, which is nice because we didn't have to check them all until we got to the correct answer. All right, so short answer. Okay, so we're starting with Pythagoras again. All right, so write down your formula. Label your triangle. So remember, C is always your hypotenuse. Sometimes they trick you by putting C on a different side, so just be aware of that. Okay, so we've got 5 squared plus 11 squared. You could probably do them in your head if you wanted to. So 25 plus 121. And then C is the square root of 25 plus 121, which is 146. And then just putting that into your calculator. All right, so when I put that into the calculator, I get 12.0830. It keeps going. We only need to do it to 2 decimal places. So always write it to more than you need, either 1 or 2 more. So your cut is here. This is the number that tells us what whether we round up or leave it. So because it is less than 5, we're just going to leave C as 12.08. All right, let's do the same for the next one. So writing the formula, labeling your triangle, doesn't matter which one is A or B, as long as C is your longest side. A is 14, B is 13. All right, so 14 squared, I think from memory is 196. I might just check that in a sec on my calculator. And 13 squared is 169. Cool. And then sorry, I'm just checking on my calculator. Oops. All right, so C is the square root of 196 plus 169, which is 365. So take the square root of that, and I'm going to do it to a few more decimal places than we need. All right, so cutting it there at 2, so C is equal to 19.10, 2 decimal places. All right, question 2, again, we've got some Pythagoras, so let's write C squared equals A squared plus B squared. Didn't leave you enough space to do your working out, but anyway, A's already been labelled. I'm going to call that A, this one's B, and this one's C. All right, so C is 20 squared, A is just A, and then B is 8 squared. So 20 squared is 400, and 8 squared is 64. So you've got to subtract 64 from both sides. So that goes. So A squared equals 400 minus 64. So 336. And then when we want A by itself, we take the square root of that. So A is equal to, just quickly doing it on my calculator. All right, remember to write it to a few more decimal places than you need to. So 18.3303, do your cut. All right, so just 2 decimal places, 18.33. All right, with question B, we've got C squared equals A squared plus B squared. Now these two lines here mean that these two sides are the same. So this is also side B. And this is C. So when you're doing your substitution, C is 15 squared, and A is B, and B is also B, because the two sides are the same. So I label them both as B squared. 15 squared is 225, and then I've got 2B squared. All right, so a bit of a tricky one, this one. Then we want to get B on its own. So let's divide both sides by 2. So that disappears. And I'm left with B squared equals, so 225 divided by 2, it's 112.5. And then we want to get B on its own, so we take the square root of that. So B is equal to, just quickly doing it on my calculator, 10.6066, keeps going. We just need to do 2 decimal places, so we cut here. All right, so this number here helps us decide whether we round up or not, because it's greater than 5, 5 or more, so it's 6. We're going to round up, so it's going to be 10.61. All right, so the number to the left rounds up by 1. All right, question 3, we're stating the gradient and y-intercept. So remember, when your equation is in the form y equals mx plus c, m is your gradient and c is your y-intercept. All right, so for question A, and it has to be in the form y equals mx plus c, of which these two are, which is great. So your gradient, we can just call m, is 2. And your y-intercept is -1. Okay, so gradient equals 2 and y-intercept equals -1. Or if you want to write them as coordinates, 0, -1. All right, for question B, your gradient is -6, the number in front of the x. Now your y-intercept, there's no number written there, but when you think about it, we don't usually write +0, and you can have a y-intercept that goes through 0, so your y-intercept is just 0. So your gradient equals -6, and your y-intercept is 0, which makes the coordinates 0, 0. All right, question 4, sketch the graph of the following linear relation showing the x and y intercepts. So when you're sketching, all you need is 2 points. Usually the easiest points are your x and y intercepts, especially if it's in this form, which we call intercept form. All right, so I'll do the working out under here. So to find the x-intercept, you let y equal 0. So we're going to have 3x plus 4 times 0 equals 12. So that disappears. So 3x equals 12. And just get x by itself. So x equals 4. So I'm going to put a point at x equals 4. And then we need the y-intercept. We let x equal 0. So we're going to have 3 times 0 plus 4y equals 12. So 4y equals 12. Divide both sides by 4. So y is equal to 3. So put your dot here. And I'm going to struggle a bit to draw a straight line, but let's just see how I go. All right. Now you'll need to use your own ruler. Don't freehand draw it like I have. All right, so there's your line. Make sure your line continues like mine has. Don't just do it to the 2 points. Try to draw it for the whole grid. Okay, for question B, because it's written in the form y equals 3x plus 6, you can find your x and y intercepts just like we have done, but you can also just use the information here. So I know that my gradient is 3, or actually this one's going to be a bit of a tricky one, and my y-intercept is 6. So my y-intercept is up here. Now, if I use 3, I could go up 3 and across 1, but my grid, I haven't given you enough space to do that. But now all we need is another point on that line. Okay, so you can choose anything you like. So let's do one that is actually going to work. So let's do the x-intercept. I'm just trying to think in my head what the x-intercept is going to be. So x-intercept, let y equal 0. So we're going to have 3x plus 6 equals 0. So 3x equals negative 6. Divide both sides by 3. So x is equal to negative 2. So there's negative 2 there. And when you think about it, your gradient, you go up 3. So we're going 1, 2, 3 and across. So there's another point. 1, 2, 3 and across. So we end up at that point anyway. All right, so let's draw our line. You can do a table of values if you want, but usually the x and y intercept are the easiest two to do. All right, a bit of a wonky line, but hopefully you'll use a ruler. All right, question 5, solve each of the following equations. So again, not enough space left for you, I apologize. So I might just write up here. So 2x plus 3 equals 9. So we want to get x on its own. So the first thing we do is get rid of the constant. So I'm going to subtract 3 from both sides. So I'm left with 2x equals 9 minus 3, which is 6. And then we've got 2 times x. So the opposite of multiplying is dividing. So then we're left with x equals 6 divided by 2, which is 3. And you can always check your answer by substitution. So if you finish your exam early and you want to check your answers, just substitute it back in. So if x is 3, we've got 2 times 3, which is 6. 6 plus 3 equals 9. Awesome. All right, let's do the next one. So we've got x on 3 minus 1 equals 4. All right, so we want to get x on its own. Now, because the negative 1 is not attached to a fraction or the x or anything like that, we need to get rid of that first. That minus sign is with the 1, so instead of subtracting 1, we're going to add 1 to both sides. So that disappears, and we're left with x on 3 equals 4 plus 1, which is 5. All right, so x divided by 3, the opposite of dividing by 3 is multiplying by 3. So that disappears, and x is equal to 5 times 3, which is 15. Again, you can check your answer. So 15 divided by 3 is 5. 5 minus 1 is 4. All right, question C. Now, we do have the number 5 on its own, but it's within this fraction, so we actually have to get rid of the 4 first. So I'm going to multiply both sides by 4 to get rid of that. So I'm left with 5 minus 6x equals 2 times 4, which is 8. Now we can get rid of that 5, and it's a positive 5 because the sign in front of the 5 is a plus. All right, and so unless there's a negative sign there, we got to assume it's a plus. So we're going to subtract 5 from both sides, so that disappears. So we're left with negative 6x equals 8 minus 5, which is 3. And then to get rid of the negative 6, we just divide both sides by negative 6. So that goes. So I've got a bit of space there, so I'll make use of it. X equals 3 divided by negative 6 is negative 1/2. With your negative sign, we don't tend to leave the negatives in the denominator, so either put it on your numerator or put it out the front of the fraction. So next one, we've got x's now on both sides. So I might actually rewrite this one. X minus 3 equals 5x plus 9. Now, see how the 8x is bigger than the 5x? So it's a lot easier to deal with positive numbers. So I'm going to subtract 5x from both sides. All right, so if it was the other way around, I would just make it so I was dealing with a positive number, but you know, it doesn't really matter what we do, as long as we're consistent. Whatever we do to one side, we've got to do to the other. All right, so now we're left with 3x minus 3 equals 9. So I'm going to get rid of that negative 3 by adding 3 to both sides. So we're left with 3x equals 12, and then divide both sides by 3. So x is equal to 4. And again, you can check your answer by substituting it into your equation. All right, question E. So we've got brackets now. So let's just expand the bracket. So I always encourage all my students, even my year 12s, to always draw your lines, because you'd hate to forget about a number, especially in an exam or a test, when you're probably in a bit of a rush and you're not slowing down and looking out for these potential errors. So just always draw the line so you know to do both. All right, so we've got 5 times 3x is 15x, and 5 times 2 is 10. Then 2 times 9x is 18x. 2 times negative 4 is negative 8. All right, so now it's kind of similar to the previous one we did before, and this is what I was saying, subtract the smallest value. So I've got 15x and 18x, so I'm going to subtract 15x from both sides, just so I'm dealing with positive. So what am I left with? 10 equals 18x minus 15x is 3x minus 8. All right, now to get rid of that minus 8, I'm going to plus 8 on both sides. And I am going to put the x on the left-hand side. It's just easier to read. So 10 plus 8 is 18. And then divide both sides by 3. So this question I got heaps of space. X equals 6. Again, you can substitute it into your equation to check, but I'm not going to do that because I just don't have the time. I'm just hoping that all my answers are correct. All right, so question F, we're going to expand the bracket first. So 2 times 3x is 6x, 2 times 1 is 2, and then we've got the minus 7x equals 4. All right, we do have like terms, so we've got the 6x and the minus 7x, which is going to give us negative x. Just be careful with your negatives. All right, let's get rid of that 2. So we're going to subtract 2 from both sides. 4 minus 2 is 2. Now, when you've got a negative, because we do want to make it a positive x, we don't want to leave it with a negative x, whatever is negative becomes positive, and whatever is positive becomes negative. So that 2 on the right-hand side was positive, but now I'm going to make it a negative. So notice how I've switched the sign from negative x to x, and I've switched the positive 2 to negative 2. All right, question 6. A school has 37 students in which 18 play soccer and 22 play netball. Assume that each student likes at least one activity. Find the probability that a student plays soccer. All right, I'm just going to quickly think about this. Okay, this one's easy. So we just want I was about to draw a Venn diagram, but I don't think I need to. 18 play soccer out of 37. Find the probability plays netball, so 22 over 37. How many students play both? Explain how this was calculated. Okay, so we do have to do a two-way table. So I'm going to do that over here. So we've got soccer and not soccer, netball and not netball. All right, so 18 play soccer. So it's going to go down here in the soccer column. And 22 play netball. And we have 37 altogether. All right, so we've got 18 plus what gives you 37. So is that going to be 2? Oh my gosh, 19. Sorry, I just went blank a little bit. And then we've got 8, 15. And we don't know how many play both. All right, I realize the important bit of information for this one. Student likes at least one activity, so that means the 0 has to go here. So we've got 0 students who don't play netball or soccer. Okay, that's going to be so much more helpful. All right, so this is going to be 19, 3, and this one's going to be 15. Okay, so how many students play both sports? So 3 out of 37. All right, so there's always enough information to do a table. Often it's how many play both, but this one was told me that 0 or students play at least one sport, so that meant the 0 had to go there. All right, write out the probability that the student plays both sports with correct notation. All right, so that's just the probability of S and N equals 3 over 37. Determine the probability that a student doesn't play soccer. So we want no soccer is 19 over 37. All right, extended response. A triangular course has been roped off for a cross-country run. The run starts and ends at A and goes via checkpoints B and C as shown. Draw the area of land on the following set of axes, taking point A to be 0, 0. Okay, so here's going to be point A. All right, and then when we go across 20, it's going to be C over here. And then B is at a height of 6. Oh, sorry. Height of 6 and across 8. So we're going to go to 8 and then up to 6. All right, now hopefully you would have a ruler. I obviously don't. So let's just, oh, that's looking good there. Maybe I can draw positive lines better than negative lines. Okay, and then the bottom. Whoops, a bit wonky. All right, so that's point B. Find the length of the course to one decimal place by calculating the distance AB, BC, and CA. So AB, all right, so when you think about it, there's a triangle here, and this is where Pythagoras comes in. So if you want to draw just that triangle, so it's a right angle triangle, the base is 8, the height is 6, and we're going to work out C. So C squared equals 8 squared plus 6 squared. Just going to quickly do it. So 64 plus 36. Oh, that's nice because it's going to be the square root of 100, which is 10. All right, so AB equals 10. I already know C to A is 20, but we just got to do BC now. So I'll do BC underneath. All right, so that's our other triangle. All right, so if the full length is 20 and the base of this was 8, so that makes this one 12 and this 6. We'll call this C. So C squared equals 6 squared plus 12 squared. So 36 plus 144. So what's 180? Oops, square root. All right, and we're not going to get an exact value for that, so I'll do that quickly on my calculator. All right, so we get 13.416. Doesn't say, oh, to one decimal place, so we'll do that in a sec. So BC equals 13.416 and CA, no, is 20. So we just add them all up. So the total length is 10 plus 13.4 plus 20. So 30, so it's 43.4, and it's probably in kilometers. Does it say kilometers? Yeah. All right, next question. A drink station is located at the midpoint of BC. Label the coordinates of the drink station on your axes. So BC is halfway between this point here, which is 8, 6, and C, which is 20, 0. So we're going to use those 2 points to find the halfway point. So you could probably do it from the axes, but I'm not going to. I'm going to do using the formula. So we've got 8, 6, and 20, 0. So your midpoint, remember we add our x's together. So 8 plus 20 divided by 2, comma, because we're finding a set of coordinates, and then your y's added together divided by 2. So 28 divided by 2 and 6 divided by 2. So we're going to have 14, 3. All right, so if I go up to here, find 14, 3. So there's 14 here and 3 must be there. You can kind of see that it's halfway. So 14, 3 is our midpoint of the drink station. All right, label the equation of each part of the course with the corresponding equation from below. So y equals 0 is your x-axis, so that's going to be A to C. So I'm just going to do that here. I'll see A, y equals 0. All right, there's several ways you can do these, but the features you should look for are the gradient. So for this one here, you've got a positive gradient, and this one here, you've got a negative gradient. So AB is a positive gradient and BC is a negative gradient. So I know that those two features are important in identifying them. So I'm just going to write y equals 3 on 4x, and this one is y equals a half x plus 10. Also with AB and BC is their y-intercept. So I can see here A has a y-intercept of 0. It's 0.00. And B, if I kept going, I would end up at 10. Okay, so just draw a dotted line there. You can see that it would extend all the way to across the y-axis at 10. I think that was the last question. All right, girls, good stuff. Bye-bye.